In our next section, we're going to analyze the 8 equations, and we're going to determine which type of conic section each equation represents. That's called classifying each conic section. And then we're going to rewrite each of these equations into standard form. The form that each of these equations in the bottom section are in right now is called general form. In a general form formula, all binomial squares have been multiplied or expanded out, and all like terms have been combined. After we classify each polynomial and rewrite the equation in standard form, I'm going to add one extra thing to the directions. I would like us to identify the center of each graph. Identifying the center would also help us analyze the graph if we were to actually use a coordinate grid to represent each of these equations on a graph. And it will also help us to come up with the major characteristics of your circles or ellipses, etc. Let's get started with question 9. Let's take a look at the 4 terms that I have on the left side. Only one of the 4 terms is squared. On the right side is equal to 0. What I can do to help me out is let's just classify this as a parabola first. Only one of the terms is squared. That term is a negative. Now, we can either rewrite this and move these to the other side, or we can move those to the other side. I rather always have a squared term be positive. So what I'm going to do is I'm actually going to take the first 2 terms from the left side to the right side and rewrite this. Positive x squared minus 10x. Now, this isn't standard form yet. Standard form would have a binomial squared. 4py equals x squared, so I need something squared. Now, I can't have an x squared and an x term. This must be represented as a binomial squared. What we're going to need to do is to complete the square and add a constant to both sides. Divide by 2, negative 5, square it, and add that to both sides. We're adding 25 to both sides, and this is our new equation. The quantity y plus 4 is equal to the quantity x minus 5 squared. This is our equation for a parabola. Where's the center of this parabola? Now, parabolas don't have centers. What they do have is a vertex. The vertex is the center of this parabola, and the vertex would have coordinates of positive 5 and negative 4. That first one is done. This is our standard form. If you feel like factoring out your greatest common factor of 1, now you see that the 1 represents the value of 4p, and it's 4py equals an x quantity squared, and it has been translated. This is the translation part of today's lesson, is figuring out where these graphs have shifted. Let's analyze the equation for number 10. I have 4 terms on the left side. I only have one term that is a y squared term. Nothing else is squared. That also makes the first equation, just like the first equation, the second equation is another parabola. I said earlier I like to operate where the squared term is positive, so I'm going to move the 2 y terms to the other side. So I'm going to keep the x minus the 49 on the left. I'm going to add 2y to both sides and add 20y to both sides. What I need to do now is to complete a square, but now that we know that there's a coefficient here, that makes things a little more complicated. I'm going to rewrite the left-hand side and leave room for a quantity that I'm going to later add. Next, I'm going to factor the greatest common factor of 2 out and leave a blank inside the square I'm about to complete. Much like the first one, the number 25 completes the square inside of the parentheses. I'm not going to add 25 to this side because the coefficient of 2 multiplies the 25, and I've really increased the right hand side by 50 by placing a 25 inside the parentheses. So I will add 50 on the left. The quantity x plus 1 is equal to 2 times the quantity y plus 5 squared. If you want to move the 2 to the other side and make it look and resemble more like a standard form, we would divide both sides by 2 to eliminate the 2 that I just erased. This is the representation of the value of 4p. 4px equals the quantity y plus 5 squared. Where's the center of this parabola? Again, we don't call it a center because it is a parabola. It is the vertex. Now this is the y-coordinate, and this is where we come out with the x-coordinate. This is where the x-coordinate comes from. -1, -5 would be the vertex. So there you have it. There's the first two. Question number 11 is another parabola. We're going to keep the x squared and the 2x on this side. I'm going to move the y minus 1 to the other side. X squared plus 2x plus some number equals -y plus 1 plus some number. Take the 2, the linear coefficient, divide by 2, square it, and add to both sides. Completed the square, x plus 1 squared equals -1 plus -1y plus 2. It might be more helpful to divide out a greatest common factor. Sometimes you may want to actually switch the sides so it looks more like 4py equals an x squared, but let's just finish this the way it is. I'm going to factor out a -1, so I'll have a y minus 2. So if I divide each of these by a -1 and bring it to the outside, then both of the signs will switch inside of the parentheses. -1 is the value of 4p. Where's the center? Again, we call it a vertex. -1 and +2. Now it's tricky because over here you're like, I think that the y-coordinate will be negative, but when this coefficient is negative, you do have to factor it out. Let's take a look at number 12. Here's the first example where I have an x squared and a y squared at the same time. They're both being added to each other, which makes this either a circle or an ellipse. The coefficients of the x and the y squared are equal, which makes this a circle. Identifying the conic section will help me figure out what the standard form equation should look like. Our standard form equation will have an x quantity squared. It will have a y quantity squared added to that, and it will equal the radius squared. I just did two things. I moved the 9 to the other side because that's where the radius squared is supposed to be equal, and I've set up two squares to complete. Take the linear coefficient, divide it by 2, square it, and add that quantity to both sides. Take the linear coefficient, -2, divide it by 2, square it, and add it to both sides. Combine like terms on the right-hand side. These are opposites. And let's rewrite this in standard form as a quantity of y and a quantity of x added together. This would be x plus 3, quantity squared. This would be y minus 1, quantity squared. So where's the center of the circle? The center of our circle is -3 and +1. Okay, I'm going to stop here, and we're going to do 4 more in our next video.